Welcome at video conference number 2. Its task is to evaluate all the activities within bionics and safety.
Hello everyone, from Cyprus. We want to welcome you all to our today conference.
Let's start from bionics.
Bionics is the interdisciplinary area of knowledge studying the building and rules of operation of organisms and adapting the rules in technology, especially in automation and construction of technical devices working as models of the organisms. It tries to get to know and use the processes controlling the action of organisms in different branches of technology, mainly in automation, electronics, and mechanics. Patents prepared by scientists use solutions appearing in nature. Working out new solutions thanks to biomimetic will enable to reduce the randoms in researches as well as easier generation of new solutions. For study and copying of details of construction from living forms is very promising because it turns out that these forms are developed very well and the solutions that we can see in nature are not yet applied in devices. In medicine, bionics means replacing or supporting all source organs and body parts with devices which very well imitate natural functioning in contrast to prostheses. Here, cochlear implants for not hearing people are the most well known.
Bionic implants differ from mesh prostheses by imitating the original action very closely, or often supersede it.
The surface of implants that contact the body might be made of biomedical materials such as titanium, silicone, or apatite, depending on what is the most functional. In some cases, implants contain electronics, for example, artificial pacemaker and software implants. Some implants are bioactive, such as subcutaneous drug delivery devices in the form of implantable teeth.
Dentistry is the most popular is dental implants to replace lost teeth. Implants are also used, for example, to place exoprostheses.
Cochlear implants may help provide hearing in patients who are deaf because of damage to sensory hair cells in their cochleas. These sensory cells, unlike most of the other cells in the body, never regenerate.
Bionic hand scientists have created a neural interface, which provides sensory information from the artificial hand to the brain. The interface is able to connect the nervous system of the patient with artificial sensors built into the prosthesis so that the user is able to control complex movements of the hand and fingers.
Spinal disc implants. These are breakthrough in terms of technology but also surgery. This is because it was necessary to work out to create new operating methods, allowing implanting lumbar disc. The artificial disc can be complete follow properly to the well-known and protected tissue of the hip joint stick. Hip joint is changed into the prosthetic tissue. The similar situation is with a stick disc. The stick disc is removed and in its place, the artificial disc is made.
Artificial hair. The artificial hair is with vestibular cavity and inner prosthetic with bone not orthopically. It plays complete top of the president's vestibula. Covers and they are both portable power equipment now in geometry. The artificial hair has improved the cerebral of president.
The development of the areas of biomedical engineering such as biomaterials, nanotechnology and biomechanics result in the increased opportunities, not only in implantology, but also affected other aspects of our lives. Students seek examples of application bionic models in medicine. 1. Bipedal locomotion machines. 2. Artificial muscle machine. 3. Prosthesis of sensory organs. 4. Electronic and electrochemical neural networks. 5. Physicometrical molecular models of organic matter. 6. Artificial intelligence of electronic computing machines. 7. Perception. 8. Mathematical modeling and disease. 6. Hemostat, glucostat, pressure switch.
We participated in different lessons and deepened our knowledge of bionics. During informational technology lesson, we solved problem types in a spreadsheet. We got to know processes in nature that are used in technology thanks to bionics. We solved tasks related to Japanese Shinkansen train, fish plane, and wind power plants. We presented our solution to the task in spreadsheet. The lesson was very interesting and made us aware that bionics is present in our everyday life.
Another information technology lesson concerns modeling and simulations. We learned the definitions of modeling and computer simulation. We got to know examples of various everyday items which were created thanks to bionics. These were, for example, salt shaker, Velcro, fabric replacing wool, the car of the company Mercedes-Benz, Shinkansen train, artificial snake searching victims of disasters, parachute, impeller of a helicopter, bath mat with suction cups, pliers, oil pans, bionic pliers, and many others. We gave examples of computer simulations in motorization, astrophysics, chemistry, architecture, aviation, medicine, meteorology, reconstruction of the events that took place in the past. Second class was a summary of the lesson.
During the IT lesson, we had the chance to create some algorithms and then according to them, we had the chance to program our Lego robots to follow our instruction. I have to say that this experience was very important.
The lessons of mathematics were also very interesting. One of the lessons concerned calculating the length of prosthetic arms and legs on the basis of the skeletal system. During the lesson of physics, we presented and named simple machines which a man uses in everyday life to make his work easier. There was a discussion of double-sided and one-sided levers present in a human body. We checked the validity of the equipoise condition of double-sided lever in a specific practical situation. We used the equipoise condition for calculating the length of an arm or body weight in the double-sided lever. We also indicated arms and forecast affecting in the simple machines, a screwdriver, a wheelbarrow, a pair of scissors.
During technology lessons, we constructed different types of robots. Most of the robots were of our own ideas. We used our creativity and imagination to construct them. The projects were really innovative. We are proud of ourselves.
In the framework of the European project here in Minds program of activities, the pupils of our school participating in its realization had the opportunity to attend a speech regarding evaluation and assessment of the Lego robots' potential in effort to make the lesson first more attractive and interesting to the pupils. Here, teachers undertook to prepare working papers on the subjects of mathematics and physics. Another working paper has also been prepared referring to a lesson subject which is relevant to the recycling of materials and the use of the Lego robots in integrated once again.
All the time we improve our English. One of the lessons concerning bionics was bionics vocabulary. During the lesson we brainstormed our associations connected with bionics.
We listened to a speaking avatar in Voki describing the definition of bionics and tried to explain how we understand it. After reading a text concerning bionics presented by means of multimedia presentation, we did the true-false exercise.
My favorite lesson was Bionic Robot, Stages of Valetta, association with the word disabled, brainstorming, discussions, how can we help the disabled, watching the video Bionic Robot, listening comprehension, exercise filling the spaces with missing information, programming the robot with bionic hand according to the instruction of another group, description of the robot with the bionic hand.
Here are the examples of our robots used in bionics. Bionic Eye. This is a robot used to read colors and measure distance from the colored objects. The device reads the color while being close to it. Moving in dark places, it is able to determine how far from a colored object there is a particular person. We have built our robot for color-blind people and programmed it in such a way to make it easier for them to function in the society. Firstly, in a three-dimensional program, Lego Digital Designer, we built a prototype of our device, designing it virtually. Next, we created a real robot, and finally, we tested it. The device works perfectly. Good job.
Having deepened our knowledge of bionics, we have designed and constructed a bionic hand. This is a robot hand. It helps people who have lost their own hands.
Earlier this year, we had the chance to attend a lesson subject session relating to the use of an electronic apparatus entitled Lego Digital Designer that assists in designing a materialization of robot models. Further on, we did design our own robot models concerning ecology issues and their realization step by step.
We deepened our knowledge of safety at home, in city, country and space. Safety at home. 1. Keep matches and lights out of the light. 2. Have proper and working smoke detectors. 3. Keep small children away when you are cooking.
Always close the doors. Do not tell anyone your personal details. Do not leave the stove on. Mount CCTV cameras. When you leave your house, do not post a message about in the social networks. Buy a robot to guard your house.
Safety rules in the city. Do not go into the unknown places you may get lost. Do not talk to strangers. Keep your pleasure of sex in the safe. Please, mobile money use out when crossing the streets. Don't get into the cars of strangers. Do not walk alone at night. Go along streets.
Safety in town. 1. Introduction. According to the Western Europe educational schemes, the so-called street class tutors should work with troublesome children and teenagers. 2. The authorities shouldn't only open new multifunctional sports fields, called or league or leaguelets, but also making them available to be used by children after school and in their free time. 3. Engage in numerous non-governmental organizations to help improve the citizens' safety. 4. Obeying the traffic rules, cross the street only when you see the green light blinking. 5. Tell the police about the misdoubts about domestic violence or not properly parked car. 6. When shopping, remember to enter your payment card's PIN number properly. 7. Don't talk to strangers met in the street. 8. Remember to keep your city clean. 9. Don't devastate blocks, buildings, or traffic signs. 10. Take care about the environment. 10 forward.
Safety in the country. Appropriately trained and well-equipped army, proper passport checks, better security systems at the airports, import the food from known and trusted suppliers, improve roads, build border crossings with the European Union member countries, reduce growing fossil fuels, build more sewage treatment plants instead of factories, establishing the sewage system.
the ban on having and using weapons. You have to guard the borders of the Earth so our planet will not raid it. You should also wear protective suits so the hazardous substances and gases that are present in the outer place do not penetrate our body and causes dangerous disease. You should also wear pads so not to be injured by the rocks and are flying in the space. You should also travel as far from the sun as it is possible to not to burn yourself.
Examples of our robots in safety. Our robot is used to protect various places, like stadiums, shops, and police. It is able to disarm a bomb. It has a propeller, which can stop things that are thrown in its direction. It can recognize faces and saves them in a database of police.
The robot's task is to climb the mountain tops in order to save people in need. It is able to move on rocky and high mountain slopes. It has a function of a hot chocolate in order to warm people frozen to the bone. It has the sense of equilibrium, and thanks to that, it is able to balance on the mountain edges. It is helpful to many lifeguards and helps them in faster and more effective reaching injured people. The robot is the best lifeguard. It is very clever and has an artificial intelligence specially programmed for the protection of human life on dangerous snowy and icy mountain peaks. A little first-aid kit is always close at hand. A few safety ropes, wedges, and climbing irons.
The French robot of the Russian project Sever Vitor is used for our border security. It is able to detect any movement near the borders and respond immediately. The robot is also equipped with an advanced metal detector that enables finding any kind of weapon even 50 kilometers away. This robot detects terrorists and overpowers them. It's a great solution to keep our country safe.
The robot is Fred Martin. Martin is multi-purpose and has the word fit. Its 4 wheels ensure its good adhesion. It is useful in different weather conditions. Special lasers mounted on it detected noise. It has 2 modes, detection and discernment. This is a perfect robot in case of loss.
All the ideas were very interesting and innovative. Thank you for today's conference. See you in another conference. Bye.